Hey everyone, and a massive welcome to the PyLadies Rivers community. I am so incredibly stoked you're hanging out with me today for this special explainer. We're going to treat this as a really fun, low-stress practice session to level up your coding skills. Today, we're diving into some brilliant programming puzzles and solutions from Jason R. Briggs's book, Python for Kids. But hey, do not let that title fool you for a second. The concepts we're covering are absolutely foundational for any developer, whether you're 8 or 80. We're going to break down some fantastic structural tools and logic exercises that will seriously sharpen those Python fundamentals.
So here's our quick roadmap for the explainer today. First up, Python basics with lists and logic, then visualizing code with turtles, recycling code using functions, mastering classes and objects, and finally, building your first game. I really want to establish a fun, approachable vibe right out of the gate for all our PyLadies tuning in. Remember, making mistakes, that's literally just part of the learning process. Sometimes your code is going to throw an error or a loop will just do something totally wild, and honestly, that is exactly how we learn to think like programmers. It's all about playful practice. All right, let's jump right into section 1, Python basics, lists, and logic. Okay, let's talk about a classic trap we have all fallen into, using a fun ninja counting puzzle. Imagine you're writing a script to see if you can fight off a certain number of ninjas. Well, if you tell your code to evaluate if the number of ninjas is less than 50 before checking if it's less than 10, your program is going to print the wrong message. Think about it. If you have 5 ninjas, 5 is obviously less than 50, right? So the program instantly prints, "That's too many," and completely skips the rest of your code. To fix this, you always have to structure your if and elif statements in the correct sequence. You gotta check the most specific condition first, like if it's less than 10, so you actually get the right message. I can fight those ninjas. Now let's see how this kind of logic builds into loops. Say we're tracking how your weight on the moon would theoretically increase year by year. Instead of sitting there manually doing that math 15 separate times, we just use a for loop. You set an initial starting weight, let's say 7.491, and the loop just automatically adds a small incremental amount for every single year that passes. The loop handles all the boring, repetitive calculation for you, instantly giving you a super clean, accurate progression over whatever time frame you want. Moving right along to section 2, visualizing code with turtles. As we get into drawing complex shapes, I want to throw a critical question out to you all. How do we simplify repetitive drawing? I mean, if you're trying to draw a massive, intricate pattern, you definitely do not want to sit at your keyboard typing move forward, turn right, move forward, turn right 1,000 times. No way. And the answer is pretty brilliant. You can start with a really basic sequence, like telling the turtle to move forward, turn 90 degrees, and move forward again, which just gives you 2 little spirals. But if you take a slightly more advanced for loop and apply it to that exact same concept, boom! You scale it up to draw a massive, incredibly complex starburst pattern. The computer handles all the heavy lifting of repeating that geometry, which saves us, literally, hundreds of lines of code. Which brings us nicely to section 3, recycling code using functions. You know, a function is really just like a recipe in your kitchen. It takes specific ingredients, which we call parameters in Python, and bakes up a consistent result. For instance, there's a great puzzle in the source material about calculating your entire family's weight on Mars. Since Mars has different gravity, you have to multiply an Earth weight by 0.3782. But instead of writing out that exact same math equation for your mom, your dad, your sister, and your dog, you just wrap it up in a function. You pass in the family member's weight as a parameter, and the function spits out the Mars weight, even keeping a running total for you. It is essentially a reusable mini-program. Let's keep the momentum going with section 4, mastering classes and objects. Okay, let's demystify these terms, because they can sound a bit dry. A class is basically just a blueprint. To use the book's completely hilarious analogy of a dancing giraffe, the class defines what a giraffe actually has, like 4 legs, and what it can do, like shuffle its left foot forward and its right foot backward. The object, on the other hand, is the actual specific thing that gets built from that blueprint. So the blueprint is the class, but Harriet the giraffe, who's actually out there dancing on your screen, that is the object. So how exactly do we bring an object to life in our code? It is surprisingly simple. Let's jump back to our drawing module for a second. First, we just import the turtle module. Next, we instantiate the pen by typing t=turtle.pen. That step right there, that's the magic. You just built a specific pen object directly from the turtle blueprint. And from that exact moment on, you can command that specific pen totally independently.
Now, here's why this is an absolute game changer. Think about drawing a sideways pitchfork. We wouldn't just use one pen for that. Because pen is a class, we can actually create 4 completely separate turtle objects from that single blueprint. We just assign each object to a different variable, like T1, T2, T3, and T4. Because they are completely independent objects, we can move them separately to easily draw all the individual arrowed lines of the pitchfork. It makes organizing and controlling your code so incredibly powerful. And finally, we have reached Section 5, Building Your First Game with Tkinter. When you play a full game, it honestly seems like magic, right? But behind the scenes, it's really just a checklist of small, manageable tasks. First, we create a Tkinter canvas, which gives us a nice window to draw in. Then, we instantiate a ball object and a paddle object, exactly like we just did with the turtle pens. We write a quick function that tells the paddle to move left and right using mouse bindings. After that, we just use some simple if statements to program the game over logic. We're basically just saying, hey, if the ball hits the bottom of the canvas, stop the game. But to make it a true game, we obviously need a score. As our source text outlines, every time the ball hits the paddle, the score should increase. So how do we actually pull that off? We bring back our trusty variables and if statements. We track the exact coordinates of both the ball and the paddle. If those coordinates intersect, boom, it registers as a hit. The ball's horizontal and vertical speeds are immediately altered so it bounces away, and at the exact same time, a score variable increments by 1 and updates the text displayed up in the corner of our canvas. It is just layers of simple logic, all working together beautifully. And there you have it, folks. From basic lists that store your favorite hobbies, to logical loops that calculate planetary weights, all the way up to object-oriented structures that let you build a fully interactive arcade game. To everyone in the PyLadies Rivers community, you now have the exact building blocks you need to bring your own ideas to life. The tools are literally right in your hands. So I'm going to leave you with this exciting challenge to ponder today. Now that you know exactly how all these pieces fit together, what incredible thing will you build next?